Now we said scalar vector is always addition all the way, but in case of vectors, it's not like that. We are very sensitive to directions. Now you can see we have parallel vectors, and we have two types of parallel vectors here. One is the same direction, while the other one is what? Opposite direction. Parallel. In such a way that along the same line. Now let's find the resultant of this. We normally call it the resultant. Resultant in this case, we have three vectors here. Because they are in the same direction, we add. You can see the arrow here. That's what determines what happened there. So we have P plus Q plus what? Z. That is the resultant vector. It's just because they are parallel. That's why we're doing it like that. Not all vector will do like that. The second one is what you are seeing there. You will see this arrow there showing that this one is coming this way, right? This one is coming the opposite vector. Very peculiar. We have to talk about the resultant here, which becomes what? P minus what? Q. Because they are not in the same direction. Then the second one, you know this one is 2 in 1. The second one is now vector in orthogonal direction, perpendicular direction, or you can call it abnormal, they are normal to each other. Now this is the raw aspect of how it is. What we normally do is that we draw, there's a law that says you draw the resultant is drawn from common points from the two vectors. This is where the resultant is. That is the diagonal represents what? The resultant. The diagonal represents what? The resultant. Then how do we do that? We carry a mirror image of what we have here. It becomes what we have here, which is now what? P. What do you observe? You will realize that we are not forming a triangle, a rectangle triangle here. And whenever we have a rectangle triangle, what comes to your mind to resolve, to get different parts of rectangle triangle is what? Pythagoras theory. And what Pythagoras theory tells us is that it is square on the longest side, which is the hypotenuse now, which is our resultant, is equal to the sum of the squares of the other two sides. So for what you are seeing here on the board, you will now realize that we have gotten our resultant. Not like every other vector of scalar addition. No. You can see that it's peculiar because the vectors are in 90-degree direction, which is the orthogonal direction. Now our arrow becomes square root of what? P squared plus what? Q squared. If you don't know how this one is done, you check on equation of indices. My video on equation of indices, you will know what happened there, where the square becomes square root on the other side of the equation. See, we are going to continue subsequently because we still have